So welcome to Artificial Intelligence Foundation and Application course. Today we will look into SAT solver. So SAT is one of the important problem in the domain of computer science, and there are many problems that can be modeled into SAT. So because of which it has gained a lot of popularity in computer science domain, and there are many. So one of the interesting thing about SAT, it is one of the first problem that was proven to be NP complete. So so this is a special problem, and there are many applications in there are many problems, many different domain problems can be addressed using this technique. For example, we can solve formal verification problem, we can look into the test generation problem, planning, scheduling, and many other kinds of problem can be mapped into SAT. So this problem has both theoretical as well as the practical challenges, and this is one of the very well-known problem in this domain. So the main objective of the SAT, basically it provides a generic framework for combinatorial reasoning at the search platform. So what does that mean? It will be clear in the upcoming slides. So this is one of the thing that it provides. So the main idea of this satisfiability problem is based upon propositional logic, or which is nothing but the simple Boolean logic that we know. And in some of the earlier classes we have looked into the constraint satisfaction problem, and interesting thing is that CSP problem can also be mapped to a SAT problem. And the popularity of SAT is because of there exist few good open source industrial grade SAT solver. So if I have a problem and if I want to solve the problem in an optimal manner, then I can simply model the problem in SAT, and I can use this open source tool to solve my problem. So this is a major advantage to model in SAT. So now come to the satisfiability problem. So what does it actually mean? So for satisfiability problem, what we need to have, first of all, we need to have a propositions or some kind of a Boolean variables. So proposition means it's nothing but a undivisible Boolean variables which can take value either true or false. So we define the set of variables, and once we define the set of variables or the propositions, we define the literals in this way. That means either it can be in the positive form or it can be in the negative form. So that will be there for every such variable. Now with this literal we can define clause. So this clause is nothing but disjunction of literals, so which are which are combined in logical or fashion. So this is one of the clause, this is another clause, and I can have many such clauses. So it is nothing but disjunction of literals. So, and the formula that we would like to verify or we would like to satisfy is the C1 logical AND with C2 and logical AND with C3 and so on and so forth. So this form is known as conjunctive normal form, or the in short we call it CNF. So all the clauses will be logically ANDed, and then it forms the final formula. So now now the goal is to find an assignment to the proposition such that my formula f is true, because once we formulate this problem in this manner, then we do not have answer whether this formula f is true or not upfront. But if we describe this formula in the disjunctive normal form, something like, if I represent my formula as like a and b and c logical, or not a, not b, c, something like this form, which is the more familiar form that we usually see. So given a Boolean formula in this form, by looking into this formula we can say that it is satisfiable or not satisfiable, because here if I choose any one of the term and then I can assign the values. So I can assign values 1, here 1, here 1, then I know this will be true because this is true. So if one of the term is true, then the whole expression will be true. But for CNF, I will not be able to say that stuff, because if I can make one of the clause to be true, that does not mean the overall formula is true, because I have to ensure that all the clauses are true. So this is one of the most important problem that we need to address. And the thing is, if f is satisfiable, if I have f is satisfiable, that means then I can find at least one valid interpretation. So interpretation means is some kind of a assignment to those propositions or those variables. So this is this when I assign 111 to these three variables, this is just one of the interpretation, and it will be called unsatisfiable if there exist uh, uh, no such valid interpretation that makes the formula to be true. So this is the basic SAT problem. So we need to define the propositions, or we need to have the variables. The variables can appear in the positive form or in the negative form, which we call it the literal. The clauses are the disjunction of literals, and the formula is the conjunction of those clauses. So effectively we represent the whole Boolean formula in the conjunctive normal form. So there are many open source tool, open source set solver that you can use for your experimentation purpose. You can model a problem in SAT, and it is actually very easy. And there exist many there exist many such tools that you can utilize for your problem. And one of the important thing that I would like to mention here, so every year there is a SAT competition held where you will be given some large test cases, and you have to solve all those test cases, and then they rank all those tools based on their performance. So if you are interested, you can look into this website, and you will get lot more uh, tools that are available in the public domain. So just to give you the idea about the tool and how simple it is, we would like to mention that how a SAT problem is defined. Or first of all, we would mention how to define a SAT formula in any one of these tool, and they follow an interesting format to specify the input, so which is known as this format DIMSCS. So it is actually the standard format to specify the clauses and its literals. So 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 the thing is, uh, when we try to, we try to specify the set of information in this format. So first of all, when we if we need to specify a comment, then it starts with the line C. That means this line will be ignored for further processing. Then one of the important line that we have to specify is how many number of variables we have and how many number of clauses we have. So these two are the important things that we have to specify, and this is the notation that we have to use, PCNF. Uh, so this is just a comment that I am specifying here, but the actual line will be something like this. That means I am defining a problem CNF which has 3 variables and 4 number of clauses. So just to specify the CNF, or just to specify the CNF, what we need to do is we need to follow this notation. So let's say I have I am solving a problem that has 3 variables and 4 clauses. So let's say my variables are A, B and C. Now in order to represent this A, B and C in this form, I will use the number 1. For B it will be 2, and for this it will be 3. So I can so by taking an integer I can represent the variable 1, 2, 3. Now I have to represent not A, not B, not C as well. So what we will do, so if I need to represent the negation of A, I simply specify -1 here. Similarly for B it will be -2. Similarly for C, not negation of C, it will be -3. Now let's say I have a CNF, or I have a clause something like A or not B or C. Now if I want to represent this clause, then I have to translate each literals in their integer form. So this will be nothing but my 1, this will be -2, this will be 3. So I specify a clause something like this. So 1, -2, 3, and this is to specify, this is just to indicate that end of the clause. Similarly we can have many other clause. So like for this clause is effectively means that it is B or okay, I made a mistake. So uh, this should not be 4 because I have 3 variables. So let me make it 3. So then it will be B or C, or I can make these to be 4. Then in that case it will be B and D. So let me change this one. So I use 4 variables, and this effectively means B or D. This clause means not of C. This clause means not A or B or C or not of D. So this will be the clause. Now the output format is for SAT, it specify either satisfiable or it is unsatisfiable. So the answer is either satisfiable or the unsatisfiable. And if it is satisfiable, then it can provide an assignment of the boolean variables that makes the formula to be true. So typically the answer will be this one definitely, and it can say that under what circumstances your formula will be true. So one of the important thing to note, the final solution that is being shown here, the interpretation of this line should be in this manner. Earlier when we are specifying the clause, these literals are connected through logical or, but now they are connected through logical and, because this is an assignment. So A should take 0, B should take 1, C should take 0, and D should take 1. So that is the interpretation. And depending on the tool, it can print additional messages to provide some information on the resource usages and statistics, so that you can actually explore of your own. Now let us come to some problem where we can actually model the problem in SAT. So this is an example from the propositional logic. This problem has been taken earlier also. So let's say it says that if Rajat is the director, then Rajat is well known. Rajat is the director, so Rajat is well known. So if we analyze, then we know that this is a true statement. So this is fine. So now let us simply see how we can actually model this in a SAT problem. So we define the proposition. So let's say A is the proposition that represents Rajat is the director, and B is the proposition that Rajat is well known. So so the given information or the given knowledge base is, if Rajat is the director, then Rajat is well known. So definitely it will be A implies B, and Rajat is the director. So so this is nothing but A. So this is the formula that have been knowledge base that have been given to us, and the goal that we want to specify is Rajat is well known, which is nothing but B. So my goal is actually B. So effectively what I want to show that if this formula F, this formula F actually implies G, which is equivalent, is meaning like A implies B and logic in A, from these two knowledge base, from these two stuff, I should be able to derive B. So that is the objective. And the thing is that from the propositional logic lecture, what we have seen, that if M is a tautology, then if logical and not of G will yield false. So which is nothing but F and G will yield empty set. And if M is satisfiable, then so is F and not of G. So what we do in order to analyze the stuff, we choose this approach. We take the negation of G, and we create the formula, and then we check for the satisfiability. If I find that it is unsatisfiable, that means it yields false, that means then my goal can be derived from the given knowledge base. So for this example, so let us model this one. So here we have two variables A and B, and we will have three clauses, because this is one clause, this is another, and this will be my third clause, because these three together forms the actual satisfiability problem. So so the first one, so we have defined two variables, three clauses. So A implies B, when we convert it into CNF form, so which is nothing but uh, this is nothing but not of A or B. So effectively I can say this is -1 and 2. I am assuming that A is 1 and B is 2. Fine. Now for A I can simply represent as 1, and this 0 is nothing but just to specify the termination of the clause. Similarly for the goal, it is B, and I have to take the negation of that, so it effectively it will be -2 0. And if I give this to a SAT solver, then it yields an unsatisfiable answer. So that means there does not exist any solution for this one. So this is unsatisfiable, and uh, then we can say the formula is actually true. And this you can easily verify. So if I write the boolean expression for this one, then it will be clear. So for the first clause it will be something like not of A or B. That will be the first one. Second is, so which is logical ANDed with A and not of B. So now if I try to resolve this one, so uh, so if I look into this part, then this yield, so this part will get cancelled. So effectively it will yield B and A and not B, which is effectively is a null set. So that will be returned by the set solver as well. So let us take the other example. So it is same. If Rajat is the director, then Rajat is well known. Rajat is not the director, so Rajat is not well known, and we know that this is false. So we use the same proposition. Rajat is the director and Rajat is well known. The formula remains the same. A implies B. Only thing is that now Rajat is not the director, so it changes to not B, and Rajat is not well known, so goal is also not B. Now if I go ahead with SAT modeling, then I have the first two things will remain the same, first two clauses, because that is the knowledge base. So only thing, the Rajat is not the director, so I have to replace I have to replace with -1 0, and the goal is changed here, so I just need to have 2 0 because this is not B, so I have to take the negation of that, and this is satisfiable, so therefore we cannot conclude this statement. So so this is just another example of propositional logic. So let us take a little bit bigger example now. So in this example, what we specify is a, a big knowledge base, something like this. So if the unicorn is mythical, then it is immortal, but if it is not mythical, then it is mortal mammal. If the unicorn is either immortal or a mammal, then it is horned. The unicorn is magical if it is horned. So this is the knowledge base, and the target is, can we prove that the unicorn is mythical, magical, horned? So individually we would like to prove this one. So we define the set of propositions. So we will be using something like this: A for mythical, B for mortal, C for mammal, D for horned, E for magical. So the formula F, or the knowledge base, first we have to represent. So if the unicorn is mythical, then it is immortal. So A implies not of B. So that will be one of the statement, and we can convert it into the CNF form. Now the second is like, but if it is not mythical, then it is mortal mammal. So that means not of A implies B and C, mortal as well as mammal. Then we can convert it into a CNF form. Then we have, if the unicorn is immortal or mammal, then it is horned. So unicorn is immortal, so not B, or a mammal C, both implies D, it is horned. Then we can convert it into CNF form because we need that one eventually to run the set tool on it. And the last statement, the unicorn is magical if it is horned. So D implies E. So we have five variables, and we can actually model this one, and the goal is individually to check whether A is true, E is true, or D is true. So so let us try to model this one. So what we need to do is we need to translate this into CNF. So we have five variables, and we have actually seven clauses. So this is one clause, this is another, second, third, fourth, fifth, sixth, and one of this will form the seventh clause. For the knowledge base, I just need six clauses, and that has been defined here. So I'm not elaborating here, but you can just see into that stuff. Like if you look into this clause, it is -1, -2. So I get -1, -2. And similarly for the other stuff as well. Now now for every goal I have to just check whether that is satisfiable or not. So now when I would like to check A, then I add this extra clause -10, and I just run sat solver and I get sat. So effectively that means I cannot conclude whether it is mythical or not. Similarly, instead of adding -10, if I would like to check E, then I would like to add -50, because whether it is magical or not. And if I give these six clauses along with -50, the clauses in blue and this one, then it yields an unsat. That means we can say the unicorn is actually magical. Similarly for the part D, if we use these six clauses in the blue and this -40, this yields unsat. So effectively it means the unicorn is actually horned one. So coming back to another problem in a propositional logic, I will quickly go over this one because it is somewhat similar, but only difference is that uh, there is a little bit difference that we will see. So let me read out the problem. So Holmes owns two suits, one black and one tweed. He always wears either a tweed suit or sandals. Whenever he wears his tweed suit and a purple shirt, he chooses to not wear a tie. He never wears the tweed suit unless he is also wearing either a purple shirt or sandal. Whenever he wears sandals, he also wears a purple shirt. Yesterday Holmes wore a bow tie. So we have to check what else did he wear. So now we have to answer what are the other things he could wear. So we have to find out all possible solution for this one. So we'll be using this notation. So black suit, tweed suit, sandals, purple shirt, tie, and 1, 2, 3, 4 for their corresponding variable. So let us try to model the problem in propositional logic. So the first one, Holmes on two suits, one black, one tweed. So uh, so the thing is, uh, it will be not BS or not TS because he can wear at most one suit at a time. So both the things cannot be so this will be true. So he always wears either a tweed suit or a sandal. So it is TS or S. Then, then for the third statement, it will be whenever he wears a tweed suit and the purple shirt, he choose not to he choose to not wear a tie. So this implies not of T, and we can convert it into CNF form. TS implies PS or S because uh, he never wears the tweed suit. He also wears either a purple shirt or a sandals. Then we can convert it into CNF, and uh, whenever he wears sandals, he also wear a purple shirt. So S implies purple shirt, PS, and that we can convert it into CNF. And Holmes wore a bow tie, so T is true also. Now the solution that we need to find out, the goal is we have to find out all satisfying solution. So in order to do that, so we have to model the formula definitely in CNF. So we have uh, we have five variables, and as of now we uh, we have six clauses, and we define this is the SAT problem as of now. Okay, now what I need to do, I will run SAT solver, and if I run a SAT solver, it says that it is actually satisfying. So uh, so so for this problem I just need to find out all satisfying solution. So this is one satisfying solution. There can be other satisfying solution. Now now if I want to find out other satisfying solution, then what I need to do, I need to consider this solution, and I have to negate this, and I have to add this set into the knowledge base so that this solution is not generated further. So we'll be adding this clause in the knowledge base, and then again we will run our set, and when we will be adding this one, this will get negated. So effectively we will add 1 2 minus 3 minus 4 minus 5, and the moment we add, still we get kind of a set solution. So 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 the thing is, when we have these clauses and these clauses as well, still it is satisfiable. So we get this as solution. What we need to do now, we have to add this clause, we have to negate this clause, we have to add this clause in the negative form in the knowledge base, and then again we have to check for satisfiability. So we add this one, and then we run the sat tool, and now it gives me an unset. So effectively it means that this, for the original problem, the satisfying solutions are this and this only. So if we choose this, if we remove these two solutions, then there will be no further solution. And by looking into this stuff, we can actually identify what other things the homes actually owe on that day. So whatever is true, that you can actually figure it out. So now I will come into an interesting problem in queens, or specifically for 8 queens problem. Now we would like to model this problem, and the problem that you know, that we have to place the queens on the chessboard such that no queens is attacking each other, and we know the queens can actually move in the horizontal direction, in the vertical direction, or in a diagonal manner. So uh, so so the thing is, so each column can have at most one queen and each row can have at most one queen. Effectively, each row and each column will have exactly one queen. Now we have to model this stuff. So uh, we define the boolean variable in this way. So uh, xij, if ij cell contains a queen, then it will be 1, otherwise it will be 0. Now we have to write the set of constraints. The constraint is something like if I choose two cells, this and this, that means xij and xij prime. So I basically represent the row and j basically represent the column. So if I vary j, I remains fixed. So if I put a queen here, then I should not be able to put any queen on this part. So xij implies not of xij prime. Similarly, for the column, if I put one queen here, then I should not be able to put any queen here. So which is again the same one. And if we put a queen, let's say here, then I should not be able to put any queen here or any queen here. So in the diagonal manner. So if it is ijth, then I have to add the appropriate offset k on both the direction. So this will give me the diagonal one. And again xij implies that I cannot put on the diagonal stuff. Now if I add only this thing, because this effectively says the actual stuff, like if I put one here, then I cannot put the other stuff. So if I have the clauses only this thing, then the interesting thing is that I can choose all xij to be 0. And if I choose all xij to be 0, then all the clauses will be satisfied. So but the thing is, I will not have any queens on the chessboard, so that will create a problem. So I need to ensure that in each row and in each column I should have one queen at least, and that we can specify through this constraint, that if we do a logical OR of along the row and along the column for each row and each column, then that will be true. So that will be my CNF for each of the row and each of the column. So that will give me, and if we create all those CNF and we give it to the search solver, then it will provide me some solution depending on the stuff. Now let us look into Sudoku problem, how we can model this one. So first we have to define the Boolean variables, and for this variable we will like to define in this way. So xijk, that means ijth cell contains the integer k. And for Sudoku problem, you know that all 1 to 9 will be placed on each of the square of size 9, and in each row all the digit will be present, and in each column all the digit will be present from 1 to 9. So that is the constraint. Now we would like to write all those constraints in SAT. So xij is nothing but my boolean variable. So the constraint that we would like to write in this way, like if I choose, if I look into two cells, let's say this and this cell, and if I choose k for the first cell, then in any other column I should not be able to place k. So xijk implies not of xij prime and k. So on the same row I will not be able to put k anymore. Similarly, for same column, if I choose k in one of the cell, then I should not be able to put k in any other column. And similar constraint we need to put for every block of size 3 cross 3. So we have to select the index I j and I prime j prime in such a way that they lie in the same block. The thing is, again, we have to ensure that that the number, so if I choose the number k, then it should belong to each row, so that we can say that for every row and every k I should have this logical OR should be 1, because if I look into this row, if I look into this row and in this row k should appear, so if I sum over j or if I do a logical OR over the columns, then it should give me 1 or the true. So k should appear on each row, similarly k should appear on each column, and k should appear on every block. So this are the basic constraints, and also what we need to do, we have to specify the stuff that in a same cell I should not put two values, because xijk, that means uh, so that means I have, if I choose to if this situation like x111 and x112, I can make these two to be 1, so 1 appears on the first row, 2 also appears on the first row, and both belongs to the first cell. Then this is a problematic, so on the same cell it cannot belong the same number, so we can say xijk implies not of xijk prime. So if I select 1 to be placed, then I cannot put any other k on that cell. And in every cell there should be some number, because if I do not put any no number, then still it's satisfiable, so I have to put some number on every cell. And the values that have been provided, that we need to specify, like when I choose this one, that means it will be first row third column and 3 is placed, so x133 is actually true. So we have to specify what are the variables are true. So now we will see a little bit complex problem, how we can actually model this one. So this is a very interesting problem to generate a Langford sequence. So what is that sequence? So given the bag of numbers 1 1 2 2 3 3 up to nn, can they be arranged in a sequence ln such that for every I there are I numbers between two consecutive occurrence of I. For example, let's say if I choose L4, then if you look into this one, so between 2 4 there are 4 number of digits. If you look into 1, then there are exactly 1 digit between two ones. If you look into 3, then there are exactly 3 digits between this one. So the thing is, now you, so this L4 is an example. We would like to find out L3, or maybe for some other one. So how we can actually figure this L3? So how we can model the problem, how we can specify the constraint in a set. So there are many ways you can actually formulate the problem. We'll be looking into one of the elegant solution now. So what we will do, we would like to see the different combinations that are possible. Like for 1 1, there will be gap between 1 numbers. So x1 can x1 or the thing is, when I'm choosing 1, it can appear in the position 1 and or position 3, and if it is L3, then we know the length will be at most 6. So 1 can appear in position 1 or 3. One can also appear, or one can appear in 2 and 4. One can appear 3 and 5. One can appear on 4 and 6. So these are the possible configuration for 1. Similarly, for 2, these are the possible configuration. Similarly, for 3, these are the possible configuration. Now, now what I will do, the variables, the Boolean variables will be defined based on this stuff. For each row of this table will specify one Boolean variable x1, x2 up to xn. And this is easy to figure out because we are just enumerating all possible individual combinations. For 1, these are the possible combination. For 2, these are the possible combinations. For 3, these are the possible combinations. Now, the thing is, we have to write the satisfiability constant. Now, one of the thing is easy, like if we look into x1, x2, x3, x4, then one of them should be true. Not all of them cannot be, not all of them will be true. Exactly one of them has to be true. So that is one of the requirements. So I can say then x1, x2, x3 or x4, this clause should be satisfied. And the other thing is that if x1 is true, then x2 cannot be true because I have already consumed 1, so I cannot use any further 1 in position 2 and 4. So which we can actually represent using a constant something like this. If xk is true, it means xk prime is actually not true. So similarly for other numbers. So this is just we are giving an example with respect to only this part. Similarly for x5, x6, x7 we have to write the constant, x8, x9 we have to write the constant. So this is one set of constant. The other thing is if we look into the position 1, then either 1 can appear or 2 can appear or 3 can appear. So one of them must appear. That we have to ensure, and that can be ensured by saying that either x1 is true or x5 is true or x8 is true. So which is the this constant. And again, if 1 is true, then x5 cannot be true, so we have to add those constant. And so for every column we have to write this kind of constant, and once we write this constant we can give it to the set solver and we can then figure it out which will be a solution for me, and that will generate the actual stuff for me. So with this I will stop now. So in this lecture what we have observed that how we can model a problem in SAT. So the basic idea to model a problem in SAT, we have to define a set of binary variables, and we have to write the constant in the CNF form, and then we have to convert this CNF form uh, into the tool format, and then we can invoke the tool and we can get the solution. So typically this SAT solver tool produces answer like SAT or unset, and we have also seen like if I need to generate all possible solution, then we can repurpose the stuff. Once we get a solution, we negate it and add back to the in the clause, and then we solve once again, and if we keep on repeating the step we can actually generate all possible satisfying solution. and there exists the lot of open source tool which are reasonably scalable, and many problems are being mapped into SAT just to exploit this SAT tools, and this scales reasonably well, and that creates its popularity. So with this I will stop now. Thank you.